Rotational kinematics in grinder. The agenda of the topic is introduction, construction of a grinder, working of a grinder, application of rotational kinematics in grinder and its uses. So let's start with introduction. Rotational kinematics in grinder involves the study of motion and dynamics of rotating components. Key parameters include angular displacement, angular velocity, and angular acceleration. Understanding these helps analyze the performance and safety aspects of grinders commonly used for material removed in various industries. Construction of a grinder. Motor provides the power to drive the grinding wheels. Grinding wheels, the abrasive wheels that remove material during the grinding process. Spindle connects the grinding wheel to the motor and enables rotational motion. Base provides stability and support for the grinder. Guard shields the operator from sparks and debates generated during grinding. Adjustment mechanism allows for the adjustment of grinding wheel positions, angles, or depth. Power switch controls the on-off function of the grinder. Handle provides the grip for the operator to control and maneuver the grinder. Housing encases and protects the internal components. Safety features: overload protection, emergency stop, and other safety mechanisms to prevent accidents. Role of rotational kinematics in the working of a grinder. Angular displacement. The grinder typically involves a rotating component such as grinding wheel or a rotating disc. Angular displacement refers to the change in the angle of rotation of this component. In a grinder, the angular displacement is critical for determining the extent to which the material is being ground or shaped. Angular velocity. Angular velocity is the rate of change of angular displacement with respect to time. In the context of a grinder, angular velocity is essential for controlling the speed of the rotating parts. The speed of the grinding wheel or disc can impact the efficiency and quality of the grinding process. Angular acceleration. Angular acceleration is the rate of change of angular velocity. It is relevant in situations where the grinder needs to start or stop rotating rapidly. The acceleration of the rotating parts can affect the time it takes for the grinder to reach its operating speed or come to a stop. Kinematic equation. Just as linear kinematics has equations that describe the relationship between displacement, velocity, and acceleration in linear motion, rotational kinematics has its own set of equations. These equations can be applied to analyze and predict the motion of the rotating components in a grinder. Balancing. Rotational kinematics is also crucial for balancing the rotating parts of a grinder. Imbalances in the rotating components can lead to vibration and reduced precision in the grinding process. Understanding rotational dynamics helps in designing and manufacturing grinders with well-balanced rotational elements. Application of rotational kinematics in grinder. Speed control. Rotational kinematics, particularly angular velocity, is essential for controlling the speed of the grinder's rotational components, such as the grinding wheel. The desired speed is often determined based on the type of material being ground and the desired finish. Rotational kinematic equations help in setting up the appropriate motor speed and gearing systems. Material removal rate. The rate at which material is removed during the grinding process influenced by the angular velocity of the grinding wheel. Rotational kinematics equations can be used to optimize the speed of the grinder for efficient material removal while ensuring the quality of the finished product. Surface finish. The angular displacement and velocity of the grinder's rotating parts directly impact the surface finish of the workplace. Engineers use rotational kinematics to optimize these parameters, ensuring that the grinding process achieves the desired surface quality. Wheel wear and replacement. Over time, the grinding wheel can wear out, affecting its dimensions and cutting efficiency. Rotational kinematics helps in monitoring and predicting the wear on the grinding wheel, allowing a timely replacements to maintain consistent performance. Startup and braking. During startup and braking phases, angular acceleration and deceleration plays a crucial role. Rotational kinematic equations are used to design and control the motor and braking systems, ensuring smooth transitions and minimizing stress on the components. Uses of rotational kinematics. Vehicle dynamics, wheels and tires. Rotational kinematics is applied in the design and analysis of wheels and tires on vehicles. It helps engineers optimize the performance of these components, considering factors such as rolling resistance, traction, and stability. Robotics, joint movements. In robotic systems, rotational kinematics is used to describe the movement of joints. This is critical for programming and controlling robotic arms and manipulators. Sports and recreation. Angular motion in sports. Concepts of rotational kinematics are applicable in sports biometrics, biomechanics. For instance, understanding the rotation of a golf club or a tennis racket is important for analyzing and improving athletic performance. Entertainment industry, animation and CGI. Rotational kinematic principles are employed in computer graphics and animation to create realistic movements, especially for rotating or spinning objects. Agriculture, farm equipment maintenance. Grinders are used in agricultural settings for maintaining and repairing farm equipment. They help in tasks such as sharpening blades and shaping metal components. Food industry, food processing. Grinders are used in the food industry for grinding and processing various food items. For example, meat grinders are used in meat processing to produce ground meat products. Home improvement, DIY projects. Grinders are popular tools for various do-it-yourself DIY projects at home. They can be used for tasks like cutting, grinding, and polishing materials such as metal, wood, or tiles. Tool sharpening. Bench grinders are commonly used for sharpening various tools, including knives, chisels, and drill bits. The grinding wheels can be configured for different levels of coarseness. Summary. In conclusion, rotational kinematics is a fundamental branch of physics that deals with the motion of objects in rotation. It provides a framework for understanding and describing the dynamic behavior of rotational bodies, encompassing concepts such as angular displacement, angular velocity, and angular acceleration. The application of rotational kinematic extends across various fields, influencing the design, analysis, and optimization of mechanical systems and processes. Thank you.